one round of circular track. So you remember when we were doing the last topic where we did the circular speed, right? The circular distance, where you are going to take the diameter, right? For example, this is circular. So what is the formula? You are going to take the diameter, sorry, the so the circumference of the circle, right? Yes. Check your notes.
Yes, ma'am.
So now question is, an athlete completes one round of a circular track of diameter 200 meters in 40 seconds. So this is the track. Okay. So what is the diameter? I hope you all know this is the diameter, right? So this is the basically diameter. So what he is doing, he is completing one circle, one round. Okay. One round in 40 seconds. Okay. And right, so one round he's clearing. So if you want to know what is the distance, what distance is covered in one round, so what it will be equals to the circumference, right? Yes or no?
Yes, ma'am.
Yes, ma'am.
So circumference is 2 pi r, right? So 2 pi, let's just take pi is simply the pi, and r is your diameter is 200 meter, so your radius will be 100 meter, right? So that means your circumference is 200 pi. Okay, this is your circumference. So what he is doing, he is covering 200 pi. This is the distance in 40 seconds. Okay. Now, what will be the distance covered and the displacement at the end of 2 minutes 20 seconds? Now, he is completing this in 40 seconds. Okay. So, if the distance, if the time is 2 minutes 20 seconds, then how much distance he will be covering? Okay, this is very important question. You can get this question in your exam. So first of all, right, you know the distance, you know the radius, like this is for radius, so you know the circumference of the circle, right? So that means for 40 seconds, very first thing, for 40 seconds he just covered this distance. Now you have the time. Okay, you have to find the distance, right? Clear? So first of all, you know that okay, other is here. At the time, athlete 40 seconds, he was covering 200 pi meter, right? Now in a unit time, the athlete will cover 200. Like for example, he is covering 200 pi in 40 equals to 40 meters, right? But in 1 unit time, how much he will be covering? So of course 200 pi divided by 40, right? Distance upon time, speed. Yes or no?
Yes, ma'am.
Right? Speed equals to distance upon time. So this is your distance and this is your time, right? Now the athlete is running 2 meter 20 seconds. So that means he is running 140 seconds. Okay, 2 minutes is 60, right? And 20 seconds. So it is 140, right?
Yes, ma'am.
Right? So hence the total distance for this. So 200 upon 40 is the thing. This is the speed, right? And now what is the formula you have to find? Speed equals to distance upon time. You have to find the distance. So distance is going to be speed multiplied by time. Yes? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Right? So speed you already know it is this. Right? And time you already know it is 140. Right? So this is what? And you will get the distance. Clear?
Yes, ma'am.
Right? And this is your distance. Okay, I'm just repeating it again. Don't get confused. Wait a minute. Adil, you are getting it? You joined late. So I think you are not getting it. So I'm just explaining this again because this is very important question. Then we'll talk about the displacement in the same thing. So we are talking about the circular motion things. Okay. So over here it is given that an athlete completes one round of a circular track. This is the circular round. So he is completing the one round, which is the diameter is this, and in 40 seconds. So he is in 40 seconds he is completing how many, like how much distance, right? So of course you will find the circumference. So when you will find circumference, you will get this answer 200 pi. So that means he is covering 200 pi distance in 40 seconds. So what is the speed? Speed equals to distance upon time. Your distance is 200 pi and your time is 40. So this is your speed. Okay. Now with the same speed, what he is doing, he is traveling this much. This is the time. You have to find the distance covered. So distance equals to speed equals to distance upon time. So you have to find distance. So that means distance equals to speed multiplied by time. This is your speed, 20, 200 pi divided by 40 multiplied by what is your time? It is 2 minutes 20 seconds. So 2 minutes means 1 minute 60 seconds, other 1 minute 60 seconds plus 20. So it is 140 seconds, right? So divided by multiply by 140. So you will solve it. You will get this answer, which is your 220 meter. Clear?
Yes, ma'am.
Yes.
Now you have to find the displacement. After 2 minutes, see, in 40 seconds, he is covering one round. Okay, for example, this is very important, displacement part. See, just leave. Adjusting from two accounts. Okay, she left from this. Okay, just remember this is very important. See, for example, he started from here, right? So after 40 seconds, he was again here, right? So that means for one round, he is taking 40 seconds. Okay, now in total, how many how many seconds you have? You have one is first round 40, then you have 60, 60, 40 plus 120. Simple, right? It was 120, right? If I'm not wrong.
Yes.
It was 120, 140, right? 140, sorry. So in total, he has 180 seconds. So if you will divide it, you will get something like in the approx 140 seconds. 3 rounds is going to be 1 and 2 minutes he is going to come back the 200 meter, right? So 60, 60 and 20. So 60 and 60, 120, 140. 140 he is doing. So let's just take, for example, 40, then 80, right? Other round, then again 40. That means you are getting it, students. This one, displacement one. No,
Yes.
I hope. Okay, only Adil is getting. What about girls? See, this is the place. For example, he started from here, right? So after you have 40 seconds, okay? 40 seconds, he'll be again here. So that means your displacement is going to be 0, right? But now he traveled 2 minutes 20 seconds. So that means he traveled 140 seconds, okay? So let's just, this one is okay. First he came. Then again 40 seconds, he was here, right? So how many left? 100 left, okay? Then again 40, he was again here. So now if you will subtract it, how many left? 60, 60 left. Then again he'll come here. So again, how many left? Sorry, 20, 20 left? Yes. So this is 20, right? 20 are leaving. So basically he will be somewhere 20 meter away from this, right? Because every 40 seconds he is covering here. He is here, right? For every 40 seconds. So, but he is covering 140. That means 20 minutes, 20 meters are remaining. So he is going to be here. So he, from the actual position, he is going to be 20 meters away or the 200 meters away. So yes, he is 200 meters away. Clear?
Yes, ma'am.
Yes, ma'am.
So this one is clear. Okay. Wait. So you'll wait now. Let's just check how many questions we have. Accordingly, we'll do it. Okay. So first one, you are going to write it down. Just write it in a short form. Okay. No need to write the everything about this. Just write in short form. Clear? Just
Yes,
don't.
ma'am.
Yeah. Just don't copy question because you have questions. Just write question number 1 and just solve. Done, students?
Yes, ma'am.
Okay, everyone is done?
Yes.
Okay. So Joseph, next question is Joseph jogs from one end A to the other end B or the straight line 300 meter, and this is the distance, this is your time, right? And then turns around and jogs 100-meter back. So basically what is Joseph doing? He is moving here, right? And then he is moving like he moved here 300 meter, but here he came only 100 meter. Okay, then this is your another one. So you have to find the average speed and the velocity. You know the things. You have the formula of average velocity plus average velocity and average speed. So you can do this. Yes. Yes, average speed, total distance covered. So you have two distance. You'll just put the value and get average velocity, displacement. So you can see what is the displacement over here. Out of 300, he just only covered this 100 meters. So what is the displacement? Displacement is going to be 200 meter, right? Because this is the initial position, this is the final position. So what is the difference? 200 meter, right? So for velocity, you will put displacement, and for average speed, you will put total distance. I think you can do this. Yes? Yes or no? No? Tell me, students, you can do this because I'll be giving you homework.
Yes, ma'am.
Okay, only Justine can do. What about Mohammed Adil and Jeba?
Yes, ma'am, we can do.
Yes.
Yes. Adil, you were not there in the previous class. The girls practice a lot. So they can do this. And I'm expecting you can also do this. Okay. Next question is, Abdul, while driving to school, computes the average speed for his trip to be this. So average speed is already given to you, right? On his return trip along the same route, there is a less traffic and his average speed is this. What is the average speed for Abdul trip? So basically what is your two speeds are given over here, right? So you have to find the average speed in total. Okay. So you have two distance. So first of all, this average speed is given. Okay. So you will first of all, this is average speed, total distance divided by total time taken. Okay. So DD, 2D and time taken plus time taken, T1 plus T2. Okay. So you'll just put it in the formula and you'll get the answer. That here nothing is given, only average speed is given, right? So you will take distance D plus D. First distance, second distance, and time T1 and T2. Clear? You'll just put it in formula and you'll get the answer. See, 2D and T1 plus T2, 2D and T1 is basically D divided by 20. Why D divided by 20? Because you know speed equals to distance upon time. So if you have to find T, it's going to be distance upon speed. So distance is your 2D. It's D and your speed is basically one time it is 20 and another time it is 30. Right? So over here it's written D upon 20 and D upon 30 and you will solve it like this. Clear?
Yes, ma'am.
Yes.
Others? Okay. Now a motorboat starting from rest on the lake accelerates. This is the acceleration question in a straight line at a constant rate. This from this. How does the boat travel? So you have to find out that how long it's going to be travel. Like what is the distance it's going to cover. So you have the formulas. You have different formulas to find distance. S. You have different formula. You can put it in any formula and you'll get the answer. Clear?
Yes, ma'am.
Next, a driver of a car traveling at 52 km per hour applies brakes and accelerates uniformly in the opposite direction. The car stops in 5. So basically here also you have initial speed and the initial velocity or initial speed and then initial starting point, initial speed and time taken is 5 hours and the final speed you have to for the second car initial speed is again time taken is here. You'll just put the formula and you'll get the answer. Clear?
Yes, ma'am.
We discussed all this in the previous class, so I think that's easy for you people. Okay, so we'll just do the objective questions later on, this graph questions. Graphite. Okay. Now coming to some theory questions. State which of the following situation are possible and give an example for each of this. Very important question. Okay. So an object with constant acceleration but with zero velocity, right? So see, is it possible or not? So yes, it is possible. When a ball is released from height, then its initial velocity is zero, but a constant acceleration equal to acceleration due to gravity is 9.8 meter per square. Why 9.8? Because this is the basically this is the gravity force which you have to remember. Okay. So yes, is it possible? This situation is possible when the situation is possible that you have constant acceleration but zero velocity. So it is possible if you will, from the height you will make a ball fall. So what will happen? Of course, its velocity is going to be zero, but it's have the constant acceleration. It's moving downward now due to gravity. So its acceleration will be 9.8 meter per square. Okay, clear?
Yes, ma'am.
Okay. Next, an object is moving in certain direction with an acceleration in the perpendicular direction. So yes, ma'am, this is also possible. When a car is moving in a circular round, its acceleration is perpendicular to its direction to the motion at each instant. Because see, car is not moving straight. Every time she has to bend. Bend. Here, again turn. Coming here, turn. Coming here, turn. So it's moving like this. So yes, when a car is moving in a circular round, its acceleration is perpendicular to its direction of motion at each instant. Clear? So the question number 9, you'll just write the answers. Okay. Okay, done, students?
Yeah.
Okay, Jaslyn and Jeba done?
Yes, ma'am.
Hmm. Okay. Now we are going to do few questions which are graphs. Okay, very, very important. Okay. Okay. This question, you can see this is your graph. Okay. This is your graph. Figure shows the distance time graph of three objects A, B, C. Study the graph and answer the following question. You can see the graph, right? This is A, this is B, and this is C, right? So, on the basis of this, you have to answer which of the three is traveling the faster. Very important. You have seen ABC. So, which one is traveling faster? Okay. So, if you will relate it, for example, let's just take it. So, let's just take A1. So, A1 is this. A1 is this one. So, what's the speed? Basically, he is at the speed of, you can say 7, 5, 6, 7, maybe 7 or 8, something like this. Okay. With irrespective, he's starting from 7 kilometer according to R. Okay, like this. He's keeping on. He started from 0, this V1, and the C1 started from basically 3. Okay, so now which one of the which of the three is traveling faster? So we know that the slope of distance time graph of an object gives speed. If the slope will be more, its speed will be more. Among the given graph, the slope of distance time graph of object B is maximum. So the B is traveling the fastest. So you can see which one, the slope one. You can see B1, the slope, right? Others are not giving the slope. So this is very important. You know the time graph. You have drawn the time graph, distance time graph. Over there, we have drawn it like this only. Yes or no? Like this we have drawn. So is it A, B or C? B. You can see, right? It's going straight up, straight away, right? So here, that's why B is the maximum. So B is traveling the fastest. Clear?
Yes, ma'am.
This is very
Yes.
important because you will get one graph question. Either they will be asking you to draw graph or they will be asking you to read the graph. Now, are all the three ever at the same point on the road? So you can see, can you see like all of them are at the same point anytime? So we can see the distance time graph of three objects A, B, C. They will never meet at a single point. They are never at the same point. So you can see they can you see like any point they are colliding like this, like this? No, na. You have seen it, na? Can you see? No. Here you can see B and C. B and A are colliding. But we are talking about all the three. Is there any point where all the three are getting contacted? No or yes? Is there any point in the graph where all the three lines are getting intersected? Is it? No, na? They are is here also. See, B and A are interacting, but they are only two. We are talking about three. So no. So the answer is we can see. So they are never at the same point of time. Next question number 3 is how far C travels when B passes A. So you can see how far C is traveling. This is C. This one is C. Right? C is traveling. So how far it will go once it passes A? So it is basically the hypothetical object. So you don't have to go for it. Okay. Just have to calculate it like this only. See. Now you just have to calculate the box. On the distance axis, we have seen the height of 7 boxes equals to 4 kilometers. So you can see over here 1, 1, 2, 3, 4, 5. For here 1, 2, 3, 4, 5, 6, 7. 7 boxes means 7 box means 4 kilometers, right? So 7 boxes means 4 kilometer over here. So initially object C is 4 block away from the origin. So here you can see this is 4 from the B. It is just away, like from the starting. You can see C is starting from here, right? And B is here. So it is just 4 kilometers away, right? 1, 2, 3, 4 boxes away, right? But over here, the last one you can see, it is basically far away. They are in the same point basically, coming to the boxes. But so the initial distance of the C is this. The distance of the C from the origin of B passes by 8 kilometers. So this is somewhere the complicated one. So you don't have to go for it. Just remember this, that it is basically 1, 2, 3, 4, 5. So they are on the same place, but they are somewhere, according to time, they are 5.714 kilometer away from the B. Here as compared to the time. 1, 2, 1, 2, 3, 4, 5. You can see 5 blocks are here. Yes. Oh, yes. You can count it. Students, you are getting it or not? No? You can tell me. I'll just explain it again. Okay, I'll just explain. See, over here you can see this means like if you want to cover 4 kilometers, because this is the distance, so you have to go for 7 boxes. Okay. So initially object C is 4 blocks away from the origin. So you can see C is starting from here and B is here. So it is 4 block away. Okay, in the starting itself. So initial distance object C from origin is 16 divided by 7. Okay, clear? So this is basically the thing. And then the distance of object C from the origin B, like once B passes A, is 8 kilometers. So distance covered by C is A. From this 8, you are going to subtract this because that's going to pass it out. Or you can simply count the boxes. It's like 1, 2, 3, 4, 5. So somewhere answer is going to be 5 point something. So you just need to go for it. Just count that, okay, it's going to be somewhere like this. Now it's clear. You don't have to go for it. I'm just giving like this type of question you won't be getting. But yeah, you just have to remember in case you get it for an MCQ, so you have to count the boxes and the question around it. For example, you got 6.733 or one is 5.273. So of course, the near about is 5. So we'll go for 5. Clear?
Yes.
Now it's clear. Okay, girls. Girls, clear? No? I think girls are not getting. Justine and Jiba, am I audible to you?
Yes, ma'am.
Okay. Okay. Now the distance covered by B at the time of C passes is equal to 9 boxes. It's basically 9 boxes away. You can see here 5, 6, 7, 8, 9. Right? B passes A. So it is 9 boxes away. So somewhere it's going to be like this. 4 upon 7 divided by 9. So it is going to be 5.143 kilometers. Clear? So you will not write second and third, you will just write the first and second point, because this you can get in your question, that which of the following is traveling faster, and second one like will they meet at any point? Okay. Okay, students done. Yes, no, maybe.
Yes.
Jasleen, you are also done.
Yes, ma'am.
Now this one, this is speed time graph. Okay. So speed time graph is over here. You first thing is that find how far car travels in the first 4 seconds. Shade the area on the graph that represent the distance traveled by the car during the period. Okay. So you can see, of course, for the first 4 seconds. So for 4 seconds means till here. Right. So it's very simple. You'll just mark it. And this much. Easy? Yes?
Yes.
Now, which part of the graph represent the uniform motion of car? This one is important. Okay. So, for okay. Hmm. If particular under constant change during its motion, then particular motion is called uniform motion. Wait. I'm not. Hmm. Which part of the graph represent the uniform motion of the car? So here you can see this one. It's going straight. So this is uniform motion, right? So the if particle under constant speed during its motion, then particle motion is called uniform motion. Clear? So which part will represent it in uniform motion from 6th onwards, from 6 to 10, right? From 6 to 10, the object was moving in a uniform speed. Clear?
Yes.
Okay. Okay, so that's it for this chapter. Okay. So now I'm just giving you 2 minutes. Just quickly, like whatever we did in the entire chapter, just quickly go through it and let me know if you are not clear with anything. I'm planning to take your MCQ tomorrow, like MCQ test tomorrow. Okay, and after that, I'll take your one subjective test. Okay. Today, I will like from this chapter, I need to clarify your questions on graph, right? So, 30 minutes tomorrow, I'll be taking your MCQ. Tomorrow you don't have class. Yeah, tomorrow you have class. So 30 minutes I'll take your MCQ. Okay. And rest the 30 minutes we'll be doing the graph questions. Clear?
Yes.
Okay. Just in clear?
Yes, ma'am.
Okay. So just quickly go through it and let me know if anything is not clear to you.